Hello, everyone. Thank you so much for joining in today. I'm really grateful to be here and excited to share an awesome tool that has helped me personally tremendously in JavaScript project development. A quick introduction about me. I've had the privilege to attend the Nobel Week in Stockholm, Sweden. During my time in Sweden, I was able to interact with various Nobel Prize laureates such as Muhammad Yunus, who received the Nobel Peace Prize in 2006. I have also been very active in tech groups across various cities. I like to keep myself updated with the latest technological trends and have also been awarded the Facebook Secure and Private AI Scholarship. I'm actively involved in bringing fitness and technology together through my startup called Athlete. Our current concentration areas are in and around Seattle, in the state of Washington, United States. We definitely plan to expand to many other cities in the US itself and hopefully globally soon. So let's dive right into our topic of the day. So, what exactly is uh, what is TypeScript? Um, TypeScript is an open source language built primarily on JavaScript. TypeScript provides a way to describe the shape of an object, providing better documentation and allowing TypeScript to validate that your code is working correctly. All valid JavaScript code is can be considered technically as a TypeScript code. You might get type checking errors, but that won't stop you from running the resulting JavaScript. While you can go for stricter behavior, that means like you're still in control of your code, right? Adopting TypeScript is not a binary choice. You can start by kind of annotating existing JavaScript with JSDoc, and then switch a few files to be checked by TypeScript in general, and over time prepare your code base to convert completely. TypeScript is an exciting technology that has been around since 2012. It was actually implemented by Microsoft, which constantly updates and also improves the language and its tooling. TypeScript originated from kind of the shortcomings of JavaScript for the development of large-scale applications, both at Microsoft and among their external customers. The freedom of um, dynamic typing often leads to bugs that kind of not only decrease the efficiency of the programmer's work, but can also grind development to halt due to increasing cost of adding new lines of code. Therefore, the failure of JavaScript to incorporate things like types and compile time error checks makes it kind of a bad choice for server-side code in enterprise and large-scale code bases. As the tagline says, TypeScript is JavaScript that scales. Challenges while dealing with complex JavaScript code lead to demand for custom tooling to kind of ease developing of components in the language. Over the past few years, it has been used by many people and companies, making it one of the top trending languages on GitHub. In the real world, TypeScript has been used extensively in many large projects, ranging from VS Code, which is completely written in TypeScript, Angular, which is also completely written in TypeScript, uh, things like Formic or RxJS is also have also used TypeScript extensively in their development. So one might ask why TypeScript? Before jumping to all the good stuff, I guess it's fair to add a small extract on why you would want to make your life easier. I'm going to try my best to show how easy it is actually to use it and to actually enjoy it as well, without the hassle of suddenly having to write Java code. one of the main One of the first reasons I see is the insane gain of time when it comes to testing your code. For example, if you wrote any test at all before, you can count on a 10 to 20% decrease on how many you have to write. If you didn't, then you gain those extra 20% at no cost. This simple function already highlights the second problem I was going to expose. JavaScript have type already whether you like it or not. But for now, my point onward, kind of in your unit test, you need to make sure your function throws, um, your function have throw functions when arguments are null, undefined, strings, etc. It's kind of another test to make sure the function always return a proper number and not an empty value or an exception. Well, with TypeScript, as you can see, all those tests are catered for by TypeScript itself. Not only you can explicitly assert that A and B are numbers in this particular example, that the result is also number, but it also allows you to set a value as nullable or not. Back to previously mentioned point, this line of code highlights, which is for me one of the fundamental miswordings behind TypeScript. TypeScript doesn't add types to your code pretty much. JavaScript is obviously already typed. It allows you to explicitly mention the types of a variable, which is fundamentally very different. Um, some languages like Bash, for example, are very effectively not typed at all. In which case, the debate would be totally different. In JavaScript, your variables are already typed, and every time you use a function, you roll the dice on whether that function expects a number or a string, or whether it can or cannot accept a null or an undefined variable for that matter. When kind of working on a project with more than one developer, that becomes a problem. Not only issues can arise when updating dependencies, but also simply merging a PR, a pull request, can suddenly break an unrelated code simply because a function's footprint slightly changed. TypeScript, when used really smartly, can prevent all of that from happening with a minimal amount of work. We'll get on to the how part later. Perfect. Welcome to the team, John. Here's the access with the GitHub. Feel free to poke around the code to get used to it. Ever heard of this sentence before? Most likely, yes. JavaScript being what it is, you'll probably have to poke around and break a few things before getting used to any code base. This is another thing TypeScript except excels at. Intelligence integration. TypeScript, especially if you use VS Code, Visual Studio Code, will provide advanced suggestions and recommendations while you type your code. The poking has never been this satisfying. Mm, yeah, so let's dive how to kind of run TypeScript in on your machine. I'll be going fairly slowly on this one, so folks who want to like follow up or follow along, feel free to do so. Onto the exciting bit, we are going to see how to set up TypeScript in a project. See this guide like a peaceful and like scenic train ride along the sea. Final stop is TypeScript Town. Along the way, while you admire the reflection of sunshine on the calm water, you'll find a sequence of stops going from the minimal TypeScript usage to more advanced usage of it. Feel free to get off the train at stop you're most comfortable in. So the simplest way to use TypeScript is with TSC. TSC stands for TypeScript Compiler. It is a very simple tool included in TypeScript itself, actually, allowing you to compile any TypeScript file into a JavaScript file. If you are familiar with NPM, I invite you to install TypeScript locally to a project rather than globally. But proper NPM usage is out of the scope of this particular talk. Let's now create our first TypeScript file, and you can call it test.ts. TS over here, .ts over here stands for TypeScript. Is the file extension that TypeScript uses. Simply, when you compile your file with TSC, this one, TSC space test.ts, it will automatically create a test.js file next to it, which you can execute. It is a completely executable file, which was formed after running the tsc test.ts command. If you follow this guide properly all the way here, you should be able to admire your glorious Palaview 123 as your console log. The next subtopic I will be covering are the different config files or config parameters that you can alter in TypeScript and the ones that TypeScripts come with. TypeScript come with a lot of configs for you to customize your experience. I highly recommend you to use this uh, at this point, at least a generic version and a very flexible config file. The code that you can see on the screen is a very basic example of a good config file, and it is good enough to run a basic JS project. So I'll pause here for 10 to 15 seconds. If you guys want to go along and create a config file of your own, feel free to go ahead. Again, some of these parameters I'll be going kind of in depth in the following, in the following slides. But the parameters, the naming of parameters are pretty self-explanatory to kind of understand what do they exactly mean. And again, after the talk, I'll be sharing a couple of resources through the Q&A discussion portal, where you can find like the exact meanings of the parameters that the config file uses. So feel free to take a screenshot or anything as well. So, all right, moving on. In order to kind of further streamline our TSC, the TypeScript compiler project, we need to add a few additional pieces in order of the config file. The simplest way to do is by relying on the config file itself to get the input over here. If you can see the include and exclude part of it. The updated config file should look like this. This part is pretty much similar to the previous one, and this part has been added. We essentially added two things here. The include prop, which is where your source files are. In this case, we are using src as a source folder, and the dist folder where you want your output files to be. Now, if you put the test.ts in your source folder alongside with your other, like all your TypeScript files and everything, simply running TSC without arguments will give you the same kind of one-on-one structure as an output in the dist folder. Next up, in order not to have to type TSC on every change, you can actually use TSC hyphen hyphen watch instead, which will update every time you save a file. So you don't have to run the command tsc itself. It will be happening automatically in the background. And to simply close the automation, you just need to close your VS Code and it will stop automatically so that it's not running in your background continuously. Now, basic type checking for JS native feature is very cool, but obviously we kind of barely touch the surface, and there's a lot more to it. Let's take a look on how to bring in typing to your everyday coding without, messing your head or messing up your current already existing projects. First, let's start with something very simple like an introduction. And if you run this, you should have the following output. It is fairly easy, and simply adding the a colon to a variable to its type declaration. You can also type a function and its return value in the similar way. Another cool, another like very cool feature of TypeScript is the non-nullable check that you can incorporate. This might seem already a bit strict for some people, so feel free to not enable it, but it actually depends on what project and what are your project requirements actually. But you might find it is actually pretty useful in the long run. In the config file, you can simply add this, which like you can set true, you can set the strict null checks true, and it will automatically enable the not nullable check. And then you can update your file similar to this formatting. I'll wait for 10-15 seconds if people want to uh, go along with this. And it is pretty self-explanatory, but this allows you to kind of have a not nullable check of your JS files, and you don't have to write test cases or unit test cases for checking the nullability in every program that you write. I'll wait for another 10 seconds for folks to copy it down. Again, I hope you guys are having a great time. This is kind of a demo session that I'm presenting, but feel free to ask questions on the Q&A section, and I'll reply to as many questions as I can after the talk has concluded. Now, moving on, we might wonder the real question right now is, when do you need to use types and when do you not need to use them? I'm going to open a short parenthesis here. A significant amount of people will try to make you set up your TypeScript to be as strict as possible. Those people pretty much compare TypeScript to Java or C, argue that because in C everything is typed, it's natural for TypeScript be to type everything as well. Now, this is going to be a totally personal kind of decision take, and like my kind of personal take on this subject is that I I disagree with this strategy because of how kind of dynamic and flexible JavaScript itself is. Typing everything can sometimes end up in a 3-4 line declarations that can make your code ineligible for the entire thing. So our whole point of using TypeScript is to make our lives easier, is to make our unit testing much easier. So that is why I kind of disagree uh, with typing everything that you can. It's also very important to kind of consider how readable your code is. Type certainly can bloat your code in such a way that only machines would enjoy your literature. But I think a lot of misunderstanding comes from the background of the JavaScript developer itself, who sees types as being a developer tool to secure the code, when originally the reason why C, for example, is typed has nothing to do with the developer. It's for the memory management. It's for the computer to understand, not the developer himself. In other words, C uses types to allocate memory efficiency uh, based on how much information you want to store in your variable. Considering that JavaScript cannot leverage this information as much, comparing it to C again, maybe it's time to consider whether or not types are kind of always beneficial when it comes to the developer itself. Anyway, the scope of this talk is not to answer that particular question, but I will leave it to you guys to make up your own minds and kind of decide what strategies you want to follow in your own personal projects. And again, like each project has a very different kind of need, a development design doc. So feel free to kind of play around with the tools that are available in your hand. So after this long and boring parentheses, let's go to what I consider to be a 75-25 split of TypeScript efficiency. When you write code, your building blocks are function. Typing at least the input output of each function means that on the long term, with only 25% of the work, you achieve 75% of typing protection. Every time someone updates a function, you expect it to be doing roughly the same thing. If the return or the parameters change, you will get a error. You'll get an error telling you to update your code and not to introduce any regression. The reason why typing some is not as necessary is obvious, since when you write this function, you have the whole function in view, and catching an error is way easier than catching an error done in a completely different file. And if you ended up not doing the proper thing in the function itself, consider writing unit tests to make your functions more robust instead of simply relying on more types. That is a better way to ensure your project is kind of foolproof and will not gain any difficulties uh, down the lane. If you're using React, forget about prototypes and use TypeScript to explicitly type your props and states. Something similar to this, where when you declare the class for the React project itself, you can have React.component props and states in it. There it is. You have unleashed. If you guys have been following this up, I'll wait again for like 10 seconds. But if you guys have following till now, you have unleashed the power of TypeScript on your code base. And suddenly it has been very soothing to call a function written by someone else and not have to worry about what you call it with and whether or not it's going to change or disappear. There is an additional aspect of TypeScript that you might want to sit through, though writing a public library, for example. When doing so, you probably want your typing to be a lot more explicit than than they would be otherwise. Most libraries expose as well typing files are available to you, making third-party integration a walk in the park. Sit tight, you're almost there. I'll again wait for 5 to 10 seconds if people want to copy this down or take a screenshot. All right, moving on. Let's now see and enjoy how to install a third-party typing for a library. Let us say that a project is using React and that we want typing for it. The first step would be to install React and its typing. The formatting is, this will pretty much be the first step. And this particular formatting at the rate types slash React means that you are installing the types segment of React. After this, you can run your usual TSC command. You'll definitely have to make a React project itself and open up your command and like put in the following commands itself. After this, run your usual TypeScript compiler command and your project will be working. When you executed the npm install command in the step one, npm created a new @typing folder in your node modules folder itself. As you can see, if you go in the files and see the extension of the file, it's .d.ts file. The formatting in the file extension is .d.ts, which is in TypeScript called a definition file. It looks complex, but don't worry, TypeScript actually generated those for you. You don't have to do anything with it as of now. As you can see, like I'm not going to explain in here everything that you can do with TypeScript because there are a lot of features that TypeScript have. But if you're interested in those, you can definitely find a ton of resources on the web. Um, and I'll definitely like link some as well in the Q&A section of VITO. I wanted to take some time though to show some of the more advanced typing acrobatics that you will probably be needing to step up your type game. Let's start with let's start easy with interfaces. There are a simply way there is a simple way to type your JSON object. It's good practice to start your interface name with a capital case I. That is kind of more of an industry standard rather than a personal choice. You can choose again like not to use it, but it will be much easier for other developers, other coders to read your file once like you share your project with others. I'll wait for 5 to 10 seconds if people want to copy it down. In most code bases, please avoid having the interface.ts file, like this particular file, with hundreds, like with other similar files. Be smart about your data model and keep the interface close to those generating them. Example that can be like the API folder or like the call generator itself. All right, moving on. Another useful trick is a union operator itself. Because sometimes a function can take or return multiple kinds of values, you can use the union function, this one, to expose them all. If your divergence becomes more complex, TypeScript also support overloading that you can use to kind of simplify your code base. Moving on, one of the concepts that is carried over from typed language is typecasting. Essentially, sometimes you will receive variables from outside sources without having a specific type attached to it. It will be the it will then be your job to tell TypeScript what type you want TypeScript to consider this variable to be. So this is like a sample code that demonstrate what demonstrate the same a similar situation. I will wait for 5 to 10 seconds to be able to copy down. Again, in case you want to add some self-made documentation to a library that doesn't have types, or maybe you want to force typing even libraries, then you will want to be able to create a custom type as such. Create a @types folder. It's a very simple way to actually do it. Just you have to create a @types folder at the root of your project and a subfolder with the name of the library to type. For demonstrating the same, I'm going to choose the React project again. Start by creating a definition file, and you can. This is like the sample of the definition file. You can probably call it custom.d.ts. The .d.ts is really important as that is the extension of the definition typeface. Note here, after this, update your config folder by including @types in the include section of the config file, and you'll be set. This marks the end of my presentation. I hope you guys had a great time and learned a new skill along the way. I'll definitely be uploading some resources um, online on the discussion page, which you guys be able to use. And feel free to reach out to ask any questions. My Twitter handle is Samyak Jain IND. Feel free to like tag me, tweet me, and yeah, thank you so much.